Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to learn in today's video is permutations. In our previous video, we learned combinations. This is very closer to permutations. Okay. Permutations are nothing but all possible ways of arranging the elements of a set. Now, we are going to be concerned about the every last detail, including the order of each item. Let me consider one example. Suppose you want to arrange your book on a shelf. If you have only one book and there is only one way of arranging it, am I right? Suppose you have two books, any two books. You can arrange the books in two ways. For example, if you have history and geography book first and history book next, or you can arrange in history or geography book in two orders. Am I right? So in the other words, we can say that there are two arrangements of the two books. Suppose you want to add one more book, for example math book, in the same shelf. After arranging both the books in two ways, you can put math book in one of the following ways. Let me write it on the board. Consider these two arrangements. Geography book first, history book second, and in this order, history and then geography. So I'm going to add one more book here. So these are the arrangements. Corresponding to HG, you have three other ways to arrange the books. So by counting principle, you can arrange math, geography and history books in 3 and again 3. So 3 plus 3, 6 ways, or 3 times into 2, 6 ways. So by permutation, we mean an arrangement of objects in a particular order. So in this example, we were discussing the number of permutations of one or two books. In general, if you want to find the number of permutations of n objects, n should be greater than or equal to 2. Or you can take n is greater than or equal to 1. Because without any element, you cannot arrange anything. In case if you have 1, you can arrange it starting from 1. So how can you do it? Let us see if we can find answer to this. Similar to the example we saw in the case of books, there is one permutation of one object. 2 times 1 permutation of 2 objects. 3 times 2 times 1 permutation of 3 objects. So it may be that there are n times, n minus 1 times, n minus 2. So it continues till 2 times 1. You can consider these cases. 1, 1 times 2, 1 times 2 times 3. Okay. So this is the permutations of n objects. In fact, so as you will see, we can prove a theorem. Then you can understand this concept. Before that, let us see the formula for permutation. These are the notations we use to denote the permutation. P of n comma r. Please understand the difference between the probability and this one. Probability of some event will be given. So for permutation, you will have two variables, en and then r. Sometimes in some books, it is followed that n comma k. Both are same. R and k are same. So this is another notation for permutation. And the formula is n factorial over n minus r factorial. Hope you're clear with this formula? Okay. Let me give you an important theorem in permutation, also with the proof. Statement says the total number of permutations of n objects is n times n minus 1 times n minus 2. So it keeps on going till 2 times 1. Okay. Let me show you the proof step by step. First, we have to find the number of possible arrangements of n different objects. And the first place in the arrangement can be filled in n different ways. Am I right? In case if you have n number of objects, choices to pick one object is n times. Am I right? You can pick any one among the given n objects. So, you can choose the arrangement can be filled in n different ways. Once it has been done, the second place can be filled in by any of the remaining, because you have already picked one from a bag and you will have the rest, because it cannot be replaced. So the chances of the second place can be filled in by any of the remaining n minus 1 objects. So this can be done in n minus 1 ways. Am I right? Similarly, once the first two places have been filled, the third can be filled in n minus 2 ways, and so on. It keeps on going like that. Am I right? Until we get only one chance. The last place in the arrangement can be filled only in one way, because in this case we are left with only one object, right? After picking all the elements. For example, if you have 12 colors of balls in a bag, first option would be you can pick any one among the 12. So 12 choices. And second would be already you have picked 1. So you will just have 12 minus 1, n minus 1. So 11 chances for the second ball. Am I right? So you keep on picking until for the last one you will have only one chance. Am I right? Using the counting principle, the total number of arrangements of n different objects is n times n minus 1, n minus 2, n minus 3, so on till 2 times 1. This product occurs so often in math. Am I right? So it deserves a name and a notation. So what notation will be used? Yes, it is usually denoted by n factorial. Am I right? It can be written as. Hope you're clear with this theorem. Proof is very simple. All you have to do is explain how all these are coming. These are nothing but number of chances of next events. Okay. Okay, let me take one example and show you how this theorem is applicable. Here is an example. Suppose you want to arrange your apple or arrange your fruits like apple, orange, grapes and pineapple, kiwi and strawberry fruits on a plate. In how many ways you can do it? So in this question, we are supposed to arrange. We have to arrange 6 fruits. The number of permutations of n objects. What is the general formula? N factorial. Am I right? N factorial is nothing but n times n minus 1 times n minus 2 till 2 times 1. So here n is equal to 6. 1, 2, 3, 4, 5, 6. Am I right? So therefore the number of permutations would be, you have to keep on subtracting 1 from each one. So already we have 6. So 6 minus 1 is 5, 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2 and 2 minus 1 is 1. Therefore the number of permutations for this example is going to be, the product gives me 720. Hope you get the same answer. Hope you are clear with the theorem and its application. Okay, now let us see second theorem on permutations. Here is the next theorem on permutations. The number of permutations of R objects out of n objects is n times n minus 1 times and until n minus r plus 1. The number of permutations of R objects out of n objects is usually denoted by npr. Okay, thus npr is equal to n times n minus 1 times n minus 2 till n minus r plus 1. So this is the statement of the next important theorem on permutations. Okay, let us prove this. Suppose we have to arrange objects out of n different objects. In fact, it is equivalent to filling R places, each with one of the objects out of the given n objects. Am I right? Okay. Same as the previous theorem. Imagine that there are some places like a box. The first place can be filled in by n different ways. Am I right? So once this has been done, so first one is n choices. So once we are done with this, the second place can be filled in by one of the remaining. So n minus 1 objects in n minus 1 ways. Am I right? Similarly, the third place can be filled in by n minus 2 ways. Am I right? Already we have took 2. So on, it keeps on going. And the last place, the rth place, can be filled in by n minus r minus 1. Am I right? So how can you rewrite this? You just distribute this negative sign within the parenthesis. So you'll be getting n minus r plus 1. Am I right? Please notice that we are subtracting 1, 2, 3 and the last number is r. So r minus 1. So these are the number of ways you can fill in the last place. You may easily see as to why this is so. So using the counting principle, we get the required number of arrangements of R out of n objects. So that is nothing but n times n minus 1 times n minus 2 until n minus r plus 1. Hope you are clear with this theorem. Here is another example for you for the second theorem. If you have 6 New Year greeting cards and you want to send them to 4 of your friends, in how many ways this can be done? So we have to find number of permutations of 4 objects out of 6 objects. Am I right? It means n is equal to 6 and r is equal to 4. First you have to identify what is n and r from the question. We have identified. Here it is 6p4. So this can be written as, you have to start from 6. 6 times 6 minus 1. 6 minus 2. 6 minus 3. R is equal to 4. So you have to stop at 4th one. So this is nothing but 6 times 5, 5 times 4, 4 times 3, which is 360. Therefore, cards can be sent in 360 ways. So using the factorial notation, this formula can be written as n factorial over n minus r factorial. Hope you're clear with this theorem and example. Okay. In case if you get any doubt regarding the topics we discussed in our today's video, kindly let me know. See you in the next video. Have a great